To simplify a radical, we want to remove all perfect square factors from that radical. So I'll start out by identifying some perfect squares. So 2 squared is 4, 3 squared is 9, 4 squared 16, 5 squared is 25, 6 squared 36, 7 squared 49, 8 squared 64, 9 squared is 81, and 10 squared is 100. Okay, that'll do for now. Now I want to simplify the square root of 75. So I want to remove any perfect square factors from 25. So I'll look at the list of perfect squares, and I'll look to see what's really the largest one of these perfect squares that will go evenly into 75. So if I look at the perfect squares, 4, 9, 16, 25, 36, I see that 25 will go into 75 without a remainder. So with the largest perfect square that divides into our number without a remainder. Now, the square root of separate factors, I can break it down into separate square roots. The square root of 25 is just 5, since 5 times 5 is 25. So I have 5 square root of 3. Now, if we want to add or subtract with our radicals, the number underneath the radical has to be the same. So if I have 4 square root of 3 minus 8 square root of 3, the number underneath the radical, we call that the radicand, that has to be the same. So I'll keep that radicand, I'll keep that square root of 3 as long as it's the same. And now I can subtract 4 minus 8. What I get is 4 minus 8 is negative 4 square root of 3. Now, if the radicands, the number underneath the radical, are not the same, then we want to try to simplify these radicals. That is, I'll look at 50 and look to see if there's a perfect square factor that I could remove. So if I look at my list of perfect square factors, I say, well, 25 goes into 50 twice. So I'll break that down into separate square root factors. So the square root of 25 is 5, since 5 times 5 is 25, and I'll bring down that radical too. Now 18, if I look at the perfect square factors, I'm looking to see which of these perfect square factors, perfect squares, divide evenly into 18. Well, 9 does. 9 goes in twice. So I'll break it down into separate square root factors. The square root of 9 is 3. So I'll keep the square root of 2, and I'll add the 5 plus 3. So I'm left with 8 square root of 2. Now, if I want to multiply with radicals, I'll use this property of radicals. The square root of a times the square root of b is equal to the square root of ab. So if I have the square root of 2 times the square root of 14 to multiply it, I can put it all under one radical and say 2 times 14. That gives me the square root of 28. But all radicals always have to be simplified. So I'm looking to see if there's a perfect square go back up to these perfect squares, that will divide evenly into 28. So if I look down the list, well, 4 goes evenly into 28. 4 goes into 28 7 times. So break it down as separate square root factors. So square root of 4 is 2, square root of 7. Now let's divide with some radicals. If you have a radical divided by another radical, if it helps to simplify the expression, we could put it all under one radical. We might not always want to do that, but if it helps to simplify it. So if I have the square root of 150 over the square root of 2, well, if that were all under one radical, I could simplify that. 150 over 2 is the square root of 75. And of course we have to simplify that, which we already did. We know that 25 is the largest perfect square that divides evenly into 75, and it goes 3 times. Breaking it down into separate square root factors, the square root of 25 is 5, since 5 times 5 is 25, square root of 3. And if we have something like this, 8 over the square root of 11. The square root of 11 is an irrational number. And we don't really like to leave irrational numbers in the denominator. So what we want to do is do something to it to make that irrational number rational. Well, what we can do is multiply it by another square root of 11. If you multiply square root of 11 times square root of 11, well, we'd get square root of 121, which is 11. Really, the square root of anything times itself will just undo it. But whatever we do to the denominator, we have to do to the numerator. If I multiply the denominator by the square root of 11, I have to do it to the numerator. So I have 8 times the square root of 11 over 11. Now, if you think of this radical as, like, say, maybe being in jail, maybe these are twins, the 11s, but the one is in jail. The other one's just visiting. So you can't cancel or simplify them. Now, if I have the square root of 2 over the square root of 3, again, we have the square root of 3. It's an irrational number. We don't like to leave those irrational numbers in the denominator, so I'm going to multiply it by itself, another square root of 3. And I know the square root of 3 times the square root of 3 is just 3. Whatever I do to the denominator, I have to do to the numerator. So square root of 2 times the square root of 3 is the square root of 6 over 3. We can't simplify it because we can't break that square root of 6 down, and he's like in lockdown. So it can't be reduced, it can't be simplified. That's our answer.